Hello everybody and welcome to section 2.3. Today we're going to go ahead and look at calculating limits using the limit laws. So in order to do that, we need to know what the laws are. So we are going to suppose that C is a constant. You guys, whenever we refer to something as being a constant in calculus, it just is some number. It could be 5, 7, -2, but it's a number. So we're supposing that C is a constant, and then we have the following limits. The limit as x approaches a of f of x and the limit as x approaches a of g of x. So they're both approaching the same number. Okay, if that is true, then we have the addition or sum property with limits. Okay, so the limit as x approaches a of f of x plus g of x will equal, you can find the limit of each one of those independently and then add them together. Okay. The same thing is true with subtraction. If we have the limit as x approaches a of f of x minus g of x, you can find them by themselves. The next one is bringing in a c, so that's that constant. So the limit as x approaches a of c times f of x will equal, you can go ahead and put the constant in front of the limit, okay, the number in front. Then you can calculate the limit of that function and multiply it by c. So here's a little example of that one. If we have the limit as x approaches 1 of 3x squared, what this is saying is 3 is a constant, so you can put it out in front. So we have 3 limit as x approaches 1, forgot to write that down here, of x squared. So you go ahead and plug in 1. So I'd have 3, and then 1 squared is 1. So I'd have 3 times 1. So I get 3. Okay, so I'd be a constant having that number in front. 4 is multiplication. So if I have two functions being multiplied, I could also find their limits independently and then multiply them. And then lastly, division. I could find each limit of each function and then divide them as well. Biggest thing here is your limit for the denominator cannot equal 0. Once again, that's because you can't divide by 0. Okay. We got some more laws here. The next one is if we have a function raised to a power. Okay, what we can do is find the limit of the function and then raise it to the power n. Okay, n has to be a positive integer. 7. This one is the limit as x approaches a of c. Remember, c is a constant. They're saying it is c. So here's an example. If I have the limit as x approaches 5 of 2, well, it's going to be 2. Visually, what's happening here, this is the equation y equals 2, which is a horizontal line. And it's saying as x approaches 5, so there's 5. So if I go ahead and look at my graph, as I approach it from my left and my right-hand side, you guys should see that it's still going to be the number 2. No matter where you look on this line, it's always going to be the number 2. So if it's ever a constant, the limit is just that number. Okay. The limit as x approaches a of x will equal a. Yeah, our initial instinct, you guys, with limits is to always take the number, whatever it's going to, and plug it in. So I would sub it in. So that's why that one is a. Same thing here. And then here, again. Same thing, it works with square roots. So those are our limits. Let's see. And those are our laws. We're going to go ahead and practice those in the next example, but that is the laws we're going to be using today.